Hi, my name is Steve Blyle and I'm a welder. Cutting torches like this are common in many types of shops and on construction sites. Besides welders, carpenters, plumbers, mechanics, auto body, and metal sculptors all find an occasion to use a cutting torch, and the better you learn to handle this, the more versatile it becomes. We'll be using a standard cutting torch. Pure oxygen is used for the cutting jet, and it's also mixed with either acetylene, propane, or some other commercial fuel gas to provide the preheat flames. An oxyacetylene mixture burns the hottest, somewhere around 5,800 degrees, and that's what we'll be using for our demonstrations. Many shops and individuals prefer propane because it's less expensive and available just about anywhere. Oxypropane burns around 5,300 degrees, which is plenty hot, but the rate of burn is slower, so it takes just a little longer to preheat before a cut. Either oxyacetylene or oxypropane works well for torch cutting. I'd like to describe how a cutting torch works, and this is as much of a chemistry lesson as it is cutting instruction. When oxygen comes in contact with metal, there's a chemical reaction called oxidation. Rusting is an example of a slow oxidation process. Oxygen molecules in the air combine with molecules of the metal to form an iron oxide, which is the rust. When metal is heated to cherry red, around 1800 degrees, and pure oxygen is introduced, the process speeds up and you get rapid oxidation, or combustion. That's what the cutting torch does. It actually burns the metal, producing a form of iron oxide we call slag. Now, the reason you can make a clean, controlled cut on carbon steel is that the oxides produced from this burning process have a lower melting temperature than the metal itself, and the force of the cutting jet blows the molten oxides through the cut before the metal can melt. On some metals like cast iron, stainless steel, and aluminum, the oxides that are created from burning have a higher melting temperature than the metal. So the metal itself is melting before the oxides can be blown away. You can get these metals hot enough just to melt all the way through, but it's difficult to make a clean cut. Now, before we get started, I need to mention safety. Everything we'll be working with is extremely hot, and the potential for injury to yourself, to other people, and to property is always present. In shops or construction sites, there's safety programs to help protect you. But safety is every individual's responsibility. You need to pay attention to what's going on around you and try to anticipate what will happen as a result of what you do. These torches are hot enough to burn just about anything, so when it's lit, be careful where you aim it. The molten slag blown from the cut can easily start a fire, so keep your work area clean. Move any flammable materials like solvents, paints, or fuels away from where you'll be cutting. Pay special attention to piles of sawdust, rags, or paper. These can start smoldering and you may not notice it. Always keep a fire extinguisher for all classes of fire handy and know how to use it. Frayed clothing will catch on fire, and avoid clothing made of synthetic materials. Synthetics melt to your skin if they're burned. Wear leather boots or some other protective footwear, and always wear safety glasses. It is totally uncomfortable to take a hot piece of metal in the eye, and it's not a whole lot more fun when the eye doctor has to dig it out. There isn't any way for anybody to cover every safety situation. Safety is an attitude. When you make working safely the number one priority, you'll do fine. Okay, let's take a look at the equipment we'll be using. Here we have an oxyacetylene torch setup. These bottles come in different sizes, and typically oxygen bottles are painted green and acetylene is painted black. Even though acetylene is highly flammable, oxygen bottles are by far the more dangerous. This is a high pressure bottle filled to over 2,000 pounds per square inch. If the valve is damaged or broken, this bottle is out of here like a rocket, and anything that's in front of it is gone too. You need to protect this valve, so whenever this bottle is not in use and the regulator's off, or you intend to move the bottle, you need to use the protective valve cover, even when the bottle's empty. Acetylene gas is unstable at pressures over 15 pounds per square inch, so acetone is used inside the bottle as a stabilizer. As the acetylene is being filled, it's absorbed by the acetone, and these bottles need to be straight up and down when in use. Now, whether these bottles are in a portable bottle cart or up against the wall, they need to be chained up securely. This is real important. You don't want to be able to pull them over with the hoses or knock them over. Also, these bottles are regulated by the Department of Transportation and need to be straight up and down and chained securely when transported. This is the oxygen regulator, and before you mount the regulators, stand behind the valve opening and crack the valve to blow out any dirt or moisture. The high pressure gauge reads up to 4,000 pounds per square inch and measures the pressure inside the bottle. The low pressure gauge measures the working pressure coming out of the regulator, and this is a regulator adjuster. Screwed in or clockwise increases the pressure, and screwed out decreases the pressure. The high pressure gauge on the acetylene regulator only reads up to 400 pounds per square inch, and here again that measures the pressure inside the bottle. The working pressure gauge is marked at 15 pounds. Remember, acetylene is unstable at pressures over 15 pounds. The pressure adjuster is the same, screwed in to increase the pressure, screwed out to decrease the pressure. Also, the fittings on the fuel gas regulator are notched to indicate left-handed thread. All the fittings on the fuel gas side of this equipment are notched with left-handed threads to avoid mixing the equipment and getting an oxy fuel gas mixture where you don't expect it. Generally, you'll have a red hose for acetylene and a green hose for oxygen. 1/4 inch is a standard hose size for normal cutting situations, and a section of 3/16 hose is often added at the torch end. The smaller hose is a little more flexible and easier to deal with in awkward situations. If you cut or burn these hoses, you can get repair parts at a welding supply store, and most have a crimping tool they'll let you use to install the new ferrules. Right here, I've installed flashback protectors. In case fire does head back down the torch, these stop it right here and keep it out of the hoses and regulators. This is a standard torch body. You have the main oxygen and acetylene valves. These are stainless ball seat valves, so when you close these, don't over tighten them. If you reef down on these, you may ruin the seats and the valves will leak. We'll be using a regular 90-degree cutting head. They also come with a head at a 45-degree angle, which I've used for beveling heavy steel, and they come straight for special applications. For general use, the 90-degree cutting head is the most convenient. This is the oxygen adjustment valve for the preheat flames, and here's the oxygen cutting jet lever. Now, the oxygen and acetylene aren't mixed in the torch body, they're mixed up here in the head. So there's 2 O-rings in this connection to seal the passageways. When you install the cutting head, just hand tighten the nut. Don't use a wrench or you can crush the O-rings, causing this connection to leak. And I like to line up the cutting head with the torch body valves. It's a little more convenient to make the adjustments. Now, all the equipment we've looked at so far can be used with either acetylene or propane. We set up on an acetylene bottle, but the same fuel gas regulator can be used on a common propane tank. The only piece of equipment that's different, depending on the fuel gas you use, is the cutting tip. An acetylene cutting tip is a one-piece tip. There's 4 to 6 small orifices around the outside for the preheat flames, and the larger center hole is the oxygen cutting jet orifice. A cutting tip used with propane is a 2-piece tip. The grooves on the inner piece are for the preheat flames. Because the rate of burn for propane is slower, you need a bit more preheat flame. Now, these tips come in different sizes, so let's take a look at a cutting chart. The commonly used cutting tips start at 0.0 for metals 1/8 of an inch thick, up to a number 3 for metals 2 inches thick. Notice that the same acetylene pressure, 3 to 5 pounds, is used on all the smaller tips, and even the large tip only uses 4 to 8 pounds. The oxygen pressure varies from 20 pounds to 45 pounds. The thicker the metal, the more pressure you need to get all the way through. We'll be demonstrating on some 3/8 flat bar using a single-aught tip with 5 pounds acetylene and 25 pounds oxygen. To make good cuts, you need to pay attention to the tip size and pressure settings. And cutting tip charts like this are available at welding supply stores. Now, if you don't have the exact size tip, you can still cut the metal. In my shop, I often use a single-aught tip to make small cuts on a lot of different thickness metals. But if you're setting up to cut a lot of one thickness, or you're going after the thicker metals, the right size tip will definitely do a better job. Now, these tips seal to the cutting head on this back surface, so you want to protect this from getting nicked or scratched. If you do get a leak there, the torch will make a steady popping sound. And you need to replace the tip. Besides the torch outfit, you'll need some cutting goggles. And this style fits over safety glasses. The number 5 filter lens is standard, and I use clear plastic lenses in front and in back to protect the filter lens. You need a striker, some tip cleaners, and a chipping hammer. You do want some good leather gloves because this will be hot. And when you're cutting metal that's dirty, rusted, or painted, keep a wire brush handy. Okay, let's load the system, adjust the regulators, and light the torch. Before the bottles are open, we need to make sure the valves on the torch are closed. We'll be adjusting the preheat flame with the oxygen valve on the cutting head and the main acetylene valve. And right now we want both of these closed. The oxygen supplies both the cutting jet and the preheat flame, so the main oxygen valve is opened all the way, and we'll leave that open. Now, whenever you open bottles, especially high pressure bottles like oxygen, you want to stand behind the valve and regulator, just in case something does come apart. Open the valve slowly so the pressure doesn't hammer the internal diaphragms of the regulator. Oxygen bottles are open all the way. This valve has 2 seats, one to close the bottle and the other to seal the valve stem when the bottle's open. So oxygen bottles are open all the way. Always use a bottle wrench to open the acetylene, not a crescent wrench or a pliers. These bottles are only open a quarter to half a turn, and leave the wrench in place. If something does happen and you need to shut the bottle down in a hurry, you don't want to have to look for something to do it with. Now, we'll make a cut on some 3/8 flat bar using a single-aught tip, so we want 5 pounds acetylene and 25 pounds oxygen. You get a more accurate reading when you adjust the regulator with the torch valve open. So I'll open the main acetylene valve on the torch and screw the acetylene adjuster in to get 5 pounds. Then close the torch valve again. Do the same with the oxygen. Open the torch valve, screw in the adjuster to get 25 pounds. And close the valve on the torch. Now, occasionally, you need to check the system for leaks. Oxygen and acetylene are too expensive to let float away, and if the acetylene is leaking, sooner or later it will catch on fire. A simple way to check for leaks is to close the bottle valve and watch the pressure gauges. If they stay the same, you're probably all right. If they bleed off, you have a leak. And you can find it with a liquid leak detector, like soapy water. All right, the pressures are adjusted. We don't have any leaks. Let's light and adjust the torch. Lighting and adjusting the torch is simple, but it's one more important step to making good cuts. There's 2 things we need to consider here. First, these cutting tips are designed to operate with a certain amount of gas flow that helps keep the tip from overheating. The amount of flow also determines the size of the flame. Second, we want the correct relationship between the amount of oxygen and acetylene. We'll adjust the gases to a neutral flame where both the oxygen and acetylene are totally consumed by the flame. If you're not familiar with adjusting the torch, a simple way is to open the main acetylene valve about 1/8 of a turn and light it. Slowly add acetylene until the flame just about quits producing the soot or smoke. Also, notice how the flame has started to feather out on the end. This should be pretty close to the right amount of gas flow and flame size. Once the acetylene is adjusted, slowly open the oxygen valve on the torch head and the preheat flames will appear. Keep adding oxygen slowly until the long flame comes together with the preheat flames to form sharp cones. This is a neutral flame and how we want the torch adjusted. A neutral flame produces carbon dioxide that purges air away from the heated metal and keeps it from oxidizing or burning until you push the oxygen cutting jet lever. If you don't add enough oxygen, the preheat flames won't sharpen up. This is called a reducing flame, and there's an excess of acetylene that will slow down the cut and mess up the oxygen cutting jet. If you add too much oxygen, you get an oxidizing flame. Notice how the preheat flames thin out and the increased rushing noise of the torch. While this flame is a little hotter, the excess oxygen will burn the surface of the metal and may actually slow down the progress of the cut. I'll reduce the oxygen a little. When you have a neutral flame, push the oxygen cutting jet lever all the way. If the preheat flames change, you can readjust the oxygen a little to sharpen them up. To shut the torch off, close the acetylene first, then the oxygen. This way the oxygen snuffs out the flame. If you do it backwards, you may get fire going back down the torch or end up with a little flame at the tip if your acetylene valve's leaking. This is easy to remember. The fuel gas always comes first. You turn it on first and you turn it off first. Now, while you're making the final adjustments, you can adjust the flame a little bigger or a little smaller, depending on the situation, but you can't get too radical. If the flame is too small, it'll take forever to get the metal preheated, and you may not have enough heat to sustain the cut. The flame may also pop out. If you try for too big a flame, you may not be able to adjust the preheat flames properly. But whatever the size tip or flame, always adjust it to a neutral flame. Also, when you push the oxygen cutting jet lever, you may have to readjust the flame a little bit. If the flame changes a lot, check to make sure that the main oxygen valve is open all the way. Check the oxygen pressure setting on the regulator and make sure there's enough oxygen left in the bottle. Now, when you're first lighting the torch, the soot that acetylene produces is like grease. Once you're familiar with what the flame should look like, you can add a little oxygen before you light the torch. Open the acetylene about 1/8 of a turn and give it a little oxygen. Then make your final adjustments. Adding a little oxygen before you light it just helps to eliminate all that soot from floating around. If you're using propane instead of acetylene, adjust the torch the same way. You won't get the soot and smoke, but keep the flame from jumping away from the tip. Then slowly add oxygen to get a neutral flame. Notice that there's a lot more preheat flame with a propane tip. Now, I've got a piece of 3/8 flat bar here, so let's try to make a cut. If you ever have to cut close to concrete or in the dirt, be careful. When concrete or stones get hot, they pop, sending pieces flying in every direction. Also, before you do any kind of torch cutting, you need to know where the sparks are going. Okay, let's give this a try. Looks like I got lucky on this one. So let's take a look at it and figure out how to do that. The cut is fairly straight and smooth, and there isn't much slag on the bottom side. First of all, you need to take your time, relax, and make sure everything's right before you start. This was new metal, so it was clean, and I had a straight line for a guide. I can't tell you how many times someone has drawn a line for me to cut that was so crooked, I had to ask them if they wanted it cut that crooked or if they wanted it cut straight. Give yourself a chance to make a straight cut by drawing a straight line. And when you sharpen your soapstone, try leaving one side flat so it rides right against the straight edge. Now, you want to rest your arm on the table or the work so you can be steady. You need to get comfortable. That's like the #1 rule for welders. Get comfortable. Try holding the torch gently between your thumb and forefinger right at this point. Now, you can cut in either direction, but if you're right-handed, you'll find it's easier to cut from right to left, and if you're left-handed, it's opposite. Heat the edge of the metal till it's cherry red, but you don't want it to melt. Before you push the oxygen cutting jet lever, make sure you're right on the edge or even back away from the metal a little and move into it. If that oxygen cutting jet can't get all the way through, molten metal will come right back up and contaminate the tip or even hit you in the face. When you push the cutting jet lever, push it all the way in. Keep the preheat flame up off the metal 1/16 to 1/8 of an inch or about 3 millimeters, and try not to move the torch head up and down. Have the torch nearly perpendicular to the metal and move with a steady, smooth progression across the cut. Ideally, you want to move as fast as you can and still have the oxygen cutting jet go all the way through. The slot made when cutting is called the kerf. The front edge is sort of half round, and while you're cutting, you want to watch right here and keep this spot against the cut line. When you're done, let off the cutting jet lever and turn off the torch. Let's put this all together and watch it one more time. Now this really is simple, but I've seen people make some rough cuts. So let's take a look at a few things that might help you out. Probably the #1 reason for not making a good cut is a dirty tip. Any contamination on the face or cutting jet orifice will cause the oxygen jet to swirl, slowing down the progress, widening the kerf, and gouging into the sides of the kerf. Keep some tip cleaners handy and use the file-looking thing to dress up the face. Clean the preheat orifices so the flames will sharpen up, and you absolutely need to keep the cutting jet orifice clean. In the long run, you'll save time by taking a few moments to keep your tip clean. And I clean the cutting jet orifice after every 4 or 5 cuts because it's easier to keep it clean than to let it get too messed up and have to fix it. You want the metal as clean as possible. Any impurities on the surface will take heat away from the cut, slowing down the progress. In a shop, most of the metal will be new, but when you start making repairs or modifications, use a wire brush to clean dirty or rusted metal, and paint can be burned with a torch, then brushed off. Check the bottom side too. Any contaminants on the bottom may stop the oxygen cutting jet from getting all the way through. If the preheat flames are adjusted too big or you have an oxidizing flame, the top edge of the kerf can burn and melt away. If there's not enough oxygen pressure, the cutting jet may not get all the way through. And too much oxygen pressure can cause the kerf to widen at the bottom. Now, with torch cutting like this, we're actually burning the metal, and slag is the oxides formed by this burning process. Ideally, the slag should blow through the cut. If the metal gets hot enough, the slag will stick to the bottom edge. You want the cut to progress smoothly. That's why you need a clean tip, clean metal, and the torch and regulators adjusted properly. When the progress slows down for any reason, the metal heats up and the slag will stick. Now, this happens to everybody. You can't always make a perfect cut. Generally, the slag comes off easily using a chipping hammer and hitting it back towards the edge. If you're not cutting all the way through, first, check to make sure nothing is on the bottom side of the metal. If that's okay, you may not have enough oxygen pressure or you're trying to move too fast. Instead of the slag blowing through, you can see it coming right back up in the kerf, kind of making a mess of things. When this happens, you can't just back up and start over because that slag melts before the metal and you won't be able to get all the way through. One thing you can try is to back up to where the cut is good, preheat one edge of the kerf, and cut the metal right alongside of the first cut. You will end up with some grinding to clean it up, but you can get going again. Not cutting through takes some time to fix, and you're way better off avoiding it. If the cut just stops while you're moving along, check the preheat flames to make sure you have enough heat to sustain the cut. But most likely, you're moving too fast. As long as you were cutting all the way through, you can restart right where you stopped. There's probably a little slag on the bottom side where the cut stopped, so when you preheat again, make sure the metal gets plenty hot, and always let off the cutting jet lever to preheat the metal. If that slag on the bottom side isn't hot enough, the cutting jet may not get through and it can gouge out the bottom of the kerf. Now, when you're making long cuts, you can't make the whole cut in one shot. You'll have to stop and reposition yourself. You can restart right in the kerf. If one piece is not going to be used, you can start on that edge, move up to the cut, and keep on going. On finished cuts that need to be polished out, you can cut away from the line a little, reposition yourself, and restart in the cutout. This way you can be sure not to leave gouges where you begin again. There's always a chance of gouging into the sides of the kerf when restarting, so try to keep the stops and starts to a minimum. Earlier, we made a straight cut on some 3/8 flat bar. Let's take a look at some other cutting situations. When you start trying to cut thicker metal, everything is a little more critical. It's not that it's any harder to cut, but rather that if you mess up, it's a whole lot more difficult to fix. Definitely use the right tip size and gas pressures, clean the metal, and have a good cut line. You want to have the torch head straight up and down in both directions. And sometimes I'll even have someone watch from this direction to make sure I don't tip the torch out and make the cut at an angle. You don't need to get the whole side red hot, just the top edge. Then rotate the tip back a little to catch the corner, push the cutting jet lever, rotate the tip straight up and down again, and start moving. This is 1¼ inch metal using a #1 tip with 5 pounds acetylene and 40 pounds oxygen. You want to go slow enough so the cutting jet has time to go all the way through. Too slow is better than too fast. You might have some slag stick to the metal, but that's a whole lot better than losing the cut. The thicker the metal, the more you need to take your time and be ready. You'll be a lot happier with yourself if you do it right the first time. When you're cutting thinner gauge metals, the problem you run into is that the metal gets so hot from the preheat flames that the slag sticks in the kerf and kind of welds the metal back together. If you're using a 000 tip, you can make a pretty good cut, but more often than not, these cuts are made with a tip that's too big. Try holding the torch at a steep angle in the direction of the cut and go fast. keep moving. If you hesitate at all, the metal will glue itself back together. Now, anytime you put heat to gauge metals, they will warp, especially on larger pieces. If this will affect the project you're working on, you can have the pieces sheared to size. All the cuts we've made so far have been in the flat position. If you're cutting across or horizontally, everything works about the same. For a vertical cut, you can either cut uphill or downhill. On thinner metal, you get a nicer cut traveling down because the heat's rising and you're cutting into cooler metal. On thicker metals, I like to cut up because the metal's being preheated a little. Also, if the slag isn't blowing clear, it's running down on the backside and you're cutting up into clean metal. One of the biggest factors in determining whether you cut up or down will be where you can position yourself to see the cut line. To help in making straight cuts, you can use a straight edge. And there are a lot of different styles of homemade or shop-made straight edges. This is a piece of 1-inch pipe welded to a vice grip. You can clamp it on a piece of flat bar, rest the tip against the pipe, and make the cut. A straight edge helps hold the torch steady and lets you concentrate more on a smooth travel speed. I like to use a piece of 1-inch pipe with a 1/2-inch round stock handle. It's easy to move around and good for awkward cutting positions. This one does take a little getting used to because you only get to hold the torch with one hand. This is a magnetic brass straight edge for cutting plate. Magnets hold it in place along the cut line and you can make longer cuts without stopping. These straight edges are handy, but they don't automatically guarantee a good cut. Before you can use these effectively, you need to know how to handle the torch. Now, when you're preparing metal for weld joints, you'll sometimes need to bevel the edge. On metal that's 3/8 of an inch or less, you can just grind the bevel. On thicker metals, it's easier to cut the bevel with a torch. Bevels are generally around a 30-degree angle, and ideally, the top edge should be straight. You also want to leave a flat spot called a landing on the bottom edge. When you're welding, the top edge acts as a guide to keep the finished weld bead straight, and the landing helps carry the heat so you don't burn the bottom edges away. Before you start, you can draw a line as a guide. Angle the torch so you're not cutting through the bottom corner. Because a lot of the heat is just blowing off the edge, the cut speed will be slower. If the cut stops, let off the cutting jet lever, jump out to the edge, preheat, cut back to the line, and keep on going. Using a straight edge to bevel helps keep the torch steady. On long bevels, cut out to the edge, reposition yourself, cut back into the line, and go again. You'll probably get slag sticking to the bottom edge because of the slower travel speed, but it comes off easily. Another situation you'll run into is making a cut where you don't have an edge to start on, like making a cutout for a pipe to go through. Start inside the cutout and preheat a little more than you would on the edge. Ease the cutting jet lever on and start moving the tip. The slag will come up in the kerf until you're all the way through, then move up to the line and make the cut. By moving the tip on the start, the slag won't jump up and contaminate the tip. And if it does, take a few seconds to clean the tip. Occasionally, you'll get in the position where you need to save both the inside and outside pieces. So you'll have to start right on the cut line. Here again, preheat a little hotter, ease on the cutting jet, and move the tip. When you're all the way through, cut back just a little, then go on to make the cut. You're able to cut back through the slag because everything is still hot from preheating for the start. By cutting back a little, you'll have a relatively clean place to finish. If you leave that mess, when you come all the way around to finish and the cutting jet hits the cold slag, it'll probably gouge into the sides of the kerf. Now, cutting torches like this don't like to cut through two pieces of metal at one time. Sometimes you'll get lucky, but most of the time, the second piece won't get hot enough, stopping the cutting jet from getting through, and the slag comes back up in the curve. The best you can do is to angle the torch and wallow through the top piece, blowing out the slag until you can preheat the bottom one. And this is never pretty. When you're through the first piece and preheating the second one, you need to be careful the tip doesn't get so hot that it melts. Besides cutting flat bar or plate, sooner or later you want to cut some solid round stock or rebar. These don't have an edge to start on, and keep in mind how thick this is so you can adjust the oxygen pressure to get all the way through. Get the metal good and hot, rotate the tip back a little, push the cutting jet lever, rotate the tip straight up and down, and cut it off. If you're cutting rebar, the higher ridges will get hot faster and give you a quicker start. When you're cutting pipe, you want to keep the tip of the torch pointed at the center of the pipe. Use a pipe wrap to draw a line for a square cut. If you can spin the pipe, try starting on the side and cut to the top. The cut line is easy to see and the torch is in a comfortable position. Slag will probably stick to the inside, especially on thinner walled pipe, but you can make a good square cut. Even if I'm not able to roll the pipe, I still usually start on the bottom and cut to the top, mainly because I can see the cut line better. When you're fabricating in the field or making repairs, you may need to burn a bolt hole. I like to make cross lines for a reference to help keep it round. You don't have an edge to start on, so get the metal hot, ease on the cutting jet, and move the tip. When you're all the way through, circle the torch, making the hole a little bigger every time, using the cross lines to keep the hole centered and round. You'll probably end up with some slag on the bottom side, but with practice, you'll be able to drill some pretty nice holes with a torch. For bigger holes, or if you need to cut round pieces, you can use a circle burner. The torch fits into it, and there's an adjustable point that you put in a center punch mark on the metal. Preheat fairly hot and ease into the start, keeping the tip moving. Cut back a little, then just pivot it around. If you have several holes to cut, this saves layout time and all the holes are identical. In making repairs, you may also run into the situation where you have to cut apart a T-joint. You can cut just above the weld, then start slicing it off. When you get close to the base, you start washing off the metal. Back the torch away and ease off the cutting jet lever to slow down the cutting jet. Watch the back side of the cut stream to make sure it's not gouging into the base metal. You can get pretty close washing that metal off, and it saves on the grinding time. In repairs or mechanicking, you may run into nuts and bolts that are rusted on so hard that you have to cut them off. On a bolt head, don't go for the whole thing at one time. Start at the top and slice it off. When you get to the bottom, ease off the cutting jet and wash it off, taking care not to gouge into the base metal on the back side of the cut. Small nuts that are rusted on can be cut off the same way. The whole thing will get hot enough to slice through both the nut and the bolt. On larger nuts, you won't be able to get all the way through. An easy way to get this off is to cut right alongside the bolt. Jump to the other side and do the same. Then use a hammer to knock the pieces off. Now, some of the bigger bolts are expensive, or you may not have another one available. So you can cut the nut off and leave the threads to reuse the bolt. It works about the same way as cutting the nut off. Only make the first cut away from the bolt a little, then wash it off. As soon as the threads pop through, you have to quit or you'll nick the threads. I guarantee that when you do that for somebody, you'll fool them into thinking you know what you're doing with a cutting torch. Now, we've been washing metal off with a regular cutting tip. This is a scarfing tip. The tip is angled so the oxygen cutting jet is parallel to the metal. This helps to keep from gouging into the metal on the back side. The cutting orifice is also larger to slow down and spread out the cutting jet. This tip can be used to remove weld from a joint where both pieces are going to be saved, and to gouge out a bevel while making repairs. Well, that's about it. I hope I've given you some ideas on how to handle a torch. You really won't know it though until you do it and see it for yourself at the end of your own cutting torch. Remember, keep your tip clean, get comfortable before you start, and concentrate on the cut while it's happening. Know where your sparks are going, and look up occasionally to check for fire. There's one more thing we need to do yet. When you're finished, like rolling up at the end of the day, you want to bleed the pressure off the system. Close both bottle valves. And starting with the acetylene, open the main torch valve. When all the pressure bleeds off, screw the regulator adjuster out so the next time the bottles are open, the internal diaphragms don't get hammered and there's not a lot of friction inside the regulator from the surge of gas. Close the torch valve and bleed the oxygen the same way. And you're finished. Have fun with this, and above all else, keep safety first.